In the last section of Chapter 9, we will work with conditional probability, Bayes formula, and independent events. Conditional probability is the probability of an event B occurring given that A has already occurred. If A and B are events in a sample space S and the probability of A is non-zero, then the conditional probability of B given A equals the probability of B and A occurring at the same time over the probability of A. For example, if we have a pair of fair dice, one blue and one gray, and we want to find the probability that the sum will be 8, given that both numbers are even, we need to find the probability of rolling a sum of 8 and 2 evens, and the probability of rolling 2 evens and divide them. Now, the sample space of rolling 2 fair dice has 36 outcomes, but the outcomes of 2 evens are 2 and 2, 2 and 4, 2 and 6, 4 and 2, 4 and 4, 4 and 6, 6 and 2, 6 and 4, 6 and 6. Therefore, the probability of 2 evens is 9 out of the 36 of the sample space of rolling 2 dice. And of those 9, 2, 6, 4, 4 and 6, 2 will be a sum of 8. So the probability for rolling a sum of 8 and having 2 even is 3 out of 36. The 36 will simplify, and 3 out of 9 is the answer, which is what shows in the sample space of just having 2 evens, or if we simplify that, 1 out of 3. I can solve the conditional probability formula for the probability of B intersection A, and that will be probability of A times probability of B given A. I can do that by cross multiplying, or I can solve for the denominator, which is the probability of A, and it's equal to probability of B intersection A over probability of B given A. To see an example of how to use conditional probabilities, let's assume that we have an urn that contains 5 blue and 7 gray balls, and we will pick 2 at random without replacement. We are going to draw a tree diagram for the possible outcomes, where case is BI, ball I is blue, and BI complement, ball I is not blue. So when we do our first pick, we have 2 choices. Either we will get ball 1 to be blue, 5 out of 12 probability, or we will get ball I not to be blue, 7 out of 12 probability. Now we are going to do our second pick, and the choices are that either ball 2 will be blue, given ball 1 that was blue, 4 out of 11, because we have already picked the 5th blue ball, and we have 11 left in the urn. Or it could be that ball 2 is not blue, but ball 1 was blue, 7 out of 11. There are 7 balls that are not blue and 11 in the urn. Or the second ball will be blue, but the first ball was not blue, so 5 out of 11. Or the second ball was not blue and the first ball was not blue, 6 out of 11. And the outcomes we get, if we multiply those probabilities, will be ball 1 blue and 2 blue, ball 1 blue and 2 not blue, ball 1 not blue and 2 blue, or ball 1 not blue and ball 2 not blue. And if you remember, we said above that the probability of getting B, A intersection B will be the probability of A times the probability of B given A. So I'm going to use this formula to multiply the two probabilities. So the probability B1 and B2 is 5 out of 12 times 4 out of 11, which is 20 out of 132. The probability B1 and not B2 is 5 out of 12 times 7 out of 11, which is 35 out of 132. The probability B1 not blue and B2 blue is 7 out of 12 times 5 out of 11, which is 35 out of 132. And the probability B1 not blue and B2 not blue, 7 out of 12 times 6 out of 11, 42 out of 132. You can add these probabilities over here to find them to be 132 out of 132 and confirm that you have calculated the probabilities correctly. So we have 4 outcomes, outcome 1, 2, 3, and 4. And the probability that the second ball is blue will be outcome 1 and outcome 3. So I will add those probabilities. 20 out of 132 plus 35 out of 132, and the answer will be 55 out of 132. The probability at least one of the balls is blue is outcome 1, outcome 2, or outcome 3, because they contain either 2 blue balls or 1 blue ball. And the answer to that is 20 and 35 and 35 out of 132. The answer is 90 out of 132. If the experiment of choosing 2 balls from the urn were repeated many times over and over, what would be the expected value of the number of blue balls? And the expected value is every outcome times its probability. So the answer here would be 0 balls times the probability of getting 0 blue balls, which is outcome 4, times 42 over 132, plus 1 blue ball times the probability of getting 1 blue ball, which is outcomes 2 and 3 together, 7 out of 132, plus 2 blue balls times the probability of getting 2 blue balls, which is outcome 1, 20 out of 132. So the answer is 70 plus 40 out of 132, or 110 out of 132. And when we do the division in our calculator, the answer is 0.83 repeating. So the expected value is that approximately 0.8 balls will be picked that are blue.